Hello dear aspirants, this is Dr. Saurav's class. We are solving some previous year questions which is from our statistics. So this question is telling us that for n greater than equals to 2, let epsilon 1, epsilon 2 dot our epsilon n be independent and identically distributed IID to my normal distribution from which is my from 0 and sorry, so this is okay, 0 and sigma square. So my random variables and my yi is equals to I alpha plus I square alpha square plus ei, sorry, epsilon I, and our I is my 1 to n, where sigma is greater than 0, so sigma is positive and alpha is belonging to r are the unknown parameters. Okay, then which of the following is the jointly minimal sufficient statistic for alpha comma sigma? So there are four options of this question. So we have to determine the jointly minimal sufficient statistic for alpha sigma based on the given model. So we analyze the problem using the factorization theorem and statistical properties of linear models. So the given things is this, that means our yi is equals to I alpha plus I square alpha square plus epsilon I, and my I is what? I is from 1 to n, and my epsilon I can be approximated by n the normal distribution of 0 comma sigma square, independent and identically distributed IID. Unknown parameters are alpha and sigma greater than 0. So now firstly we have to think about the likelihood function. So the density function for epsilon I, which is approximated by normal distribution at the point 0 comma sigma square, is what? This is my f of epsilon I, which is equals to 1 by root over of 2 pi sigma square and e to the power, that means exponential of e to the power minus this thing by 2 sigma square. Sorry, yeah. So now using this thing, my yi is what? That is my this. So using this, the likelihood function for y1, y2 yn is what? That is equals to L alpha comma sigma square, which is equals to the big product of I, which is running, I is running from 1 to n, that will be this, and e to the power, rather like to, yeah, okay, yi minus I alpha minus I square alpha square whole square. So this is my epsilon I square by my 2 sigma square is given here. So now we have to think about the sufficient statistics. So the factorization theorem states that a statistic T is sufficient for alpha comma lambda alpha comma sigma square. Let me change my color first. Okay, so now we can write that the factorization theorem states that a statistic T is sufficient for, yeah, if the likelihood can be factored as this, L of alpha comma sigma square per y1 y2 dot my yn, that will be equals to what? That will be equals to g of t. Yeah, so that will be my alpha comma sigma square, and into h we have to move this case. Okay, h of y1 y2 yn. So where t is a function of our y1 y2 yn. In this case we examine the structure of the quadratic terms in the likelihood. So now the quadratic forms in the data. So the likelihood depends on the following summations. The summations are what? Yeah. The total sum of yi. So now after that the weighted sum by I, which will be what? Y in I into yi, and I is running from 1 to n. After that the weighted sum by I square, that will be this. So this is my y square, and that will be yi. Yeah. So I think this is my n. So now the constant weights, that will be what? That will be my I square, and the sum of the squared observations, which will be, yeah. So the sufficient statistics must capture the dependence of the data on alpha comma sigma using the structure of the regression like model, which is my yi equals to I alpha plus I square alpha square, and this thing epsilon I. The jointly sufficient statistics are this. That means this, and this. So we can write it as our in the order tablet. So that can be written as this. Okay. So now we have to think about the we have to verify the minimal sufficiency. The minimal sufficiency ensures that the statistic contains no extraneous information. Since the above of the three terms capture all the necessary information about alpha and sigma, they form a minimal sufficient statistic. So we got the option. This is the correct option of the questions. So thank you guys. Hope you understood. Thank you.